there. I'm thrilled to be here today and welcome to this session on coding with kids. So no matter if you're a parent or maybe an expecting parent, grandparent, godparent, whatever, I hope that this presentation will give you an idea or that you leave this presentation with enough knowledge to understand when and how to start coding with kids. Before we start, a few words about myself. I'm currently working as a machine learning engineer in a German company called Innovex, where I jump from project to project. I'm currently working with Babel, the language learning app in the speech recognition team, which is a lot of fun. I enjoy working on personal projects and usually share those with the community, either on GitHub or my personal webpage. And two of the most popular repositories you might find interesting as well are Machine Learning Basics, which implements and teaches fundamental machine learning algorithms in plain Python, and My Magical Universe, I'm a big Harry Potter fan, which introduces Python features like decorators, context managers, and so on, using a world of magic. Regrettably not Harry Potter, because they have a lot of licensing and copyright infringement issues with Warner Brothers and Harry Potter, so I didn't dare to touch that. Okay, let's talk about the talk, or why I'm interested in this topic in the first place. First of all, I had no coding opportunities in my own childhood, so my parents had nothing to do with coding, neither did my friends. I had no coding classes in school. And I stumbled across coding quite late in my undergraduate degree when I had an introduction to machine learning. And I want this to be different for my own children, but also for all the other kids, especially for girls, because for me it was a revelation to discover coding and how much fun it is. Then second reason is that I love learning and teaching. I've been, for example, part of a German initiative called KI macht Schule, which translates into AI goes to school, where we give free courses on AI in German schools for kids there. Third reason is that I've always been fascinated by how the brain works, and the brain is at the core of all of our learning. And we will talk about the brain as well in this presentation. I also studied cognitive science in my undergraduate degree, so really fascinated by that topic. And last but not least, I love kids. This is actually the only picture of a real child you will see. All the other pictures were created with DALL-E 3. This is my son Theodore, one of the rare occasions when he was still young, when he fell asleep in the morning and I could get some coding work done next to him, which was really nice. Regarding the overview, we will start with the motivation for the presentation. Then we will look into brain development for the different age ranges, so that you get a better understanding of what a child can really do at a certain age. And then I want to talk about when and how to start at specific age ranges. And afterwards, I will present a few concrete tools like robots, devices, languages, platforms that you can use for the different ages to get started with. And in the end, I want to talk a bit about how children learn and how you can support them in their learning process. And then we will have a Q&A. Let's start with the motivation. So why do we want to teach kids how to code in the first place? Learning to program isn't just about learning a skill for a job. It's rather that with coding, you can create anything that you can imagine. You can create stories, art, animations, websites, and much more. It enables you to create things that you like and even have fun doing it. Of course, there are obvious advantages like improved career opportunities, but most important is for me that they learn specific skills when they learn how to code. And we will look into some of these now. These are all, of course, only examples. First of all, logical thinking. Coding helps children to develop logical thinking skills by breaking down a complex problem into smaller, more manageable parts. So they learn not only to solve a problem, but also to explain why and how they solved it that way. And this skill is, of course, essential in everyday life because it helps us to make more structured decisions and solve problems in a more efficient way. Then there's problem solving. While kids are writing their code, they are forced to solve errors that come up with their program, what we call debugging as developers. So they develop problem-solving skills by understanding how to analyze, debug, and troubleshoot their code. And these skills can be applied to everyday life situations and also to any career, and are invaluable, in my opinion. Then there is creativity. Coding helps children to develop their creativity by allowing to express themselves through code. So it encourages them to think outside the box and come up with their own unique solutions to problems. So in other words, it allows or creates room for innovation. And the last skill I chosen as an example is perseverance, which I find I love it, that picture. It was so much fun to create them with the prompts. So we all know that coding is challenging and that not every solution is simple or straightforward. And perseverance is the ability to keep moving towards an end goal, even if the path to it is difficult. So with the right encouragement, children will learn how to try again when they fail. And as a parent or tutor, with the right encouragement, and especially if you celebrate both wins and failures, you can make them stronger. Specifically, it has been proven effective to praise effort rather than outcomes. So independent of the result, you could say something like, wow, you tried really hard to solve this problem and did not give up, that's fantastic. These were a few examples now of skills that children acquire when they learn how to code. And maybe as a short summary, should all children learn how to code? In my opinion, I would say yes, but not for the sake of becoming future programmers, especially because we really don't know how programming will look like in the future. It has changed rapidly in the past years with tools like GitHub Copilot popping up, and will change even more in the upcoming years. So what we do know with a reasonable amount of certainty is that the computational thinking skills that children gain through learning how to code will remain relevant and in high demand. Now, let's look into the brain. Don't worry, it's not going to be a neuroscience lecture, just the very basics and understanding how the brain develops. I already mentioned the brain is at the core of all of our learning, so it's really important to understand how brain development looks like in the different ages to understand what a child can do. If you don't know, the brain is the most complex part of our body. It controls a lot of things, our emotions, bodily functions, our memory and thought. And it is divided into cerebral hemispheres that can be further divided into sections that specialize in different functions. So we have different parts of the brain that specialize in different functions and mature at different ages. One of the most important terms regarding brain development is neuroplasticity. So in some species, brains are mature at birth, but this is not the case for humans. The human brain matures over many, many years. And this means that as the brain develops, it can be influenced by our interactions with the environment. So, wait a second. So during the early years, when the brain is growing most rapidly, it shows a lot more plasticity than in later years. This is especially true for ages up to 3 or 4 years, where the brain is most reactive to environmental influences. This holds for positive influences like responsive caregiving, that you have appropriate stimulation, and diverse learning experiences. So you can really influence the brain development of your child in these early years and lay the foundation for their future learning. But of course, it also holds for negative influences. Let's look into how the brain develops. I generated these images to look somewhat similar to how I looked like as a baby. So you can see it as following the path in an alternative universe of little Anna-Lena learning how to code from a very young age, or you can just exchange it for any other child you know. At the birth, our brain has already 100 billion neurons, which I think is amazing, and an average of 2,500 synaptic connections per neuron. So synapses are the connections between neurons and basically the pathway along which they exchange signals and pass on signals. At birth, the brain reaches only 25% of adult size, and newborns have only basic reflexes for survival, like rooting, grasping, sucking, but no directed interactions with their environment. So no coding at this stage. Then we go on to very early childhood, so brain development from 0 to about 4 years of age. In this time, the brain develops from the bottom up. This means that primitive areas of the brain, like the brainstem, already developed during gestation and in the early months after birth. Then we have motor reflexes and sensory abilities like hearing and vision that are fairly well developed at birth and undergo rapid maturation in the first 6 months of life. We have the limbic system associated with emotional processing and emotional regulation, and the cortical areas associated with cognitive and executive functions that develop over the first 3 years. And then we have other areas that mature over much longer periods, like synapses in the neocortex, which controls higher cognitive functions, and they develop throughout the years of middle childhood and do not attain their final organization until late adolescence. So by the age of 4, the brain has grown up to 80% of adult size, but still the cognitive abilities are not developed well enough to really start with any kind of coding or computational thinking. But this changes once your child reaches about the age of 4, and now we will look into how you can get started with coding at a later age. If you're interested in all the resources that this is based on, they are listed here on the slides, and the slides are also uploaded on the page of the talk. Okay, let's look into when and how to start. First, an overview. So we can basically divide this into 4 different sections. You can get started with computational thinking and basic algorithmic thinking very early without any coding whatsoever. And there are child-friendly robots, and this is for the age of 4 up to 6, where you can get started with visual programming like Scratch we will look into a bit more. And then about 9 or 10 years of age, you can get started with textual programming. Let's look into all of these in detail. Okay, let's say age up to like 4 or 6. Here we can start teaching basic algorithmic thinking without any coding whatsoever. So for example, we know an algorithm is just a set of rules that describes how to solve a problem in a specific way or how to perform a task. And you can teach this concept using basic examples like which steps would you follow to guide a lost puppy home. And this exercises like this, and you will find lots of those on the web, help children understand step-by-step thinking. So they understand, or they will understand, how an algorithm functions by breaking down a task into smaller, more manageable parts, which helps them to think sequentially and logically. Further, by the age of about 4, a child is likely to have the motor skills and also the perceptual abilities to begin to interact with simple toys that introduce the very basics of coding. And these child-friendly robots are a good way to get started. Here on the right side, you see the B-bot, which we will also look into a bit more in the next section. As your child gets older and reaches the age of 6, they become more used to using technology, and also their eye-hand coordination improves. And also the prefrontal cortex, which is like the CEO of our brain, undergoes a big growth spurt between 5 and 8 years of age, which results in vast improvements in working memory, planning, selective attention, and inhibition. So 6 years is a good age to try out tools for visual programming like Scratch. And then even further along is around the ages of 9 or 10, children's language abilities are well developed, and also their typing skills are often sufficient to start using text-based languages. And at this age, the prefrontal cortex starts to mature and stabilize. This means that a child's executive functions like planning, organizing, thinking abstractly become more fully developed. Of course, these are all just estimates. You are the expert of your child. Observe how it's developing and what skills it already has, and when it makes sense for you to progress on to the next stage. Now that you have a rough idea of how the brain develops at the different age ranges, I want to give you some idea of specific tools you can use to get started with. We will first look into robots for very young kids. So starting at the age of 4 is the B-bot. On the left, it's a programmable floor robot designed for children from age 4 to 7. It has buttons, so it can go to the front, it can go back, right and left, and I can remember, I think, up to 130 commands, and then you press enter and it just moves along the path. And I think they're really cute. You will see a demo on the next slide. And then on the right, you see cubelets, which are physical blocks, and you can use them to introduce physical computing to children. They just snap together the blocks, and the blocks can do different things, and they build their own unique robots, and the robots then can perform actions like moving or lighting up, depending on their environment. Like if you have the hand next to the sensor, it might light up. And cubelets are also nice because they can be programmed using MakeCode, a visual programming language, later on. I always listed the prices as well because some offers are free and some are really expensive. Like with the cubelets, one cubelet is about 50 euros, so you need a lot of money to get really cool robots. Okay, this is a demo of the Bee-Bot. I just took that from YouTube, it's not my own. Yeah, so you see like how the buttons are pressed, and then you can press go. And these are cubelets. Okay, going on to the next example, the microbit, which is a small programmable device with an LED display, buttons and sensors. It is recommended for the ages of 8 or at least 8 years old. It can be used to create games, animations, interactive projects, and much more. It's programmable with a visual programming language called MakeCode, and it's quite cheap compared to other options. And then there is Zoomy, which is a tiny buildable self-driving car kit, which is for older kids. We have used this at the company I work at, Innovex, for quite a few kids events, and it's always a lot of fun, not only for the kids, but also for the adults. You can program it using Python or Blockly, and they are quite expensive, but also very powerful. For example, you can teach machine learning concepts as well by training how to drive based on your own data set. So they are really offer a lot of opportunities to learn. In last example, I added is Raspberry Pi. This is not a robot. This is rather a device, a very cheap computer that runs Linux, but also provides a set of general purpose input-output pins. So it allows you to control electronic components for physical computing, explore the Internet of Things. And you can use it to learn programming skills, build hardware projects, do home automation, and lots more. You need textual programming for being able to program a Raspberry Pi, so it's for older children, starting at least at the age of 11. Now, there are lots of other robots. I listed some more at the end of these slides, but if you know others that I haven't come across, let me know. Now, let's jump into visual programming. First of all, if you do not know what it is, in visual programming, you have an editor without writing code yourself, but you have puzzle pieces or blocks that abstract or represent code concepts like loops, variables, and so on. And you can plug them together like little puzzle pieces, which lets the users program without having to worry about syntax or the intimidation of using the command line. Oh, yeah, one of the most popular languages is Scratch, and there is a version of it for very young children, starting at the age of 5 already, which is Scratch Junior. Yeah, as it's mentioned here, it's a free app that runs on Android and iOS, and you have drag and drop blocks that you can put together to create simple programs. You see there's no text involved, it's just movement like turn around, go forward, go right, go left, and you can make the characters in the game move around. Then there is Scratch. Scratch was developed by the Scratch Foundation and the MIT. It's a free coding community and visual coding interface for kids, and they can create digital stories, games, animations. It has a lot of graphics and sounds to really bring your program to life. It's focused on kids interacting with each other, sharing their projects. It's available in many, many languages. It is recommended for kids starting at the age of 8 up to 16, they say, but I know colleagues of mine that even use Scratch for some of their projects. So it's really not that you cannot use it when you're an adult. Yeah, and you can also see an example here. It's more sophisticated. You do not write the code, but you do see the code snippets and also text in them. Then there is Blockly as a last example, which is also free, developed by Google, and it's also has a block-based editor. It's actually the basis for lots of other visual programming languages. So it's the basis of Scratch, of MakeCode, and it's a bit more low-level compared to them. So it offers you more flexibility. You can create custom blocks, and also in the editor, which you can see down here, you have the blocks, but on the right side, you always have the text-based version of the code for different programming languages, and you can export the text form and run it right away. Now, going on to Code Combat, I can see that the images are not so clearly visible, but yeah, you can check out the slides if you're interested in seeing them more clearly. Code Combat is about game-based learning. So if your child is into gaming, this might be a good way to get started. In Code Combat, students learn real Python, JavaScript, or any of the other languages here by playing a game from beginning to end. It's available in many countries, so many languages, but it is not for free. So you have different subscription plans. You can do self-paced learning or guided learning. They say that you can start already with 7 years of age. I find that a bit early, especially because it is textual programming from the very beginning. But it seems as they have students that start as early as that. Yeah, there you can see again that kids are very different from what they can do at different ages. Okay, and then, sorry. A completely different approach is Heady. Heady is a gradual programming language. So learning a programming language can be overwhelming because learners have to learn concepts like loops at the same time as they have to learn syntax like quotation marks and round brackets. And in Heady, concepts are first introduced with very little syntax and then they are refined. So each level adds new concepts and syntactic complexity. It's a web-based and free interface, and it mimics the way in which we learn a language. For example, when you print something with Python, you usually have print, then you have the round brackets and the quotation mark around the string, and in Heady you just first do print and write the text. You do not worry about the quotation marks or the brackets. They are introduced at later stages. At the end of the Heady level sequence, kids master a subset of syntactically valid Python, and they recommend it for age 10 plus. And then if you're looking for more traditional programming languages for your child to progress onto, you can best do that with 12 years of age and beyond. Recommended are languages like Python that are easy to get started with, or those that the World Wide Web is built on, like HTML, CSS, and JavaScript. And there are lots of courses online that you can find that introduce these languages to children. And I mentioned this already, but just to make sure that you remember, so if you try Python or a textual programming language, it does not mean that you cannot go back to using Scratch or switch between Scratch or any other visual programming language and a text-based one for different projects. Okay, then there are offers like online and on-site classes. Some kids just learn better in a group or in a classroom. There are Tinker, Code Wizard, and Code.org. Code.org also offers teaching material if you want to teach coding to more kids, or maybe you're a teacher. And then there are two things that are from Germany, but I know that there are similar ones in all other countries. There's the Hacker School, which really offers, without any prior experience, courses for kids starting at 11 years of age, on web development, on building your own games, on lots of different things. And then there's IT for Kids, where they go into schools very early, at the third grade, and give coding classes, which is in Germany still a big thing and missing in most of the schools. Then more ideas is that you can check out local events. For example, there's the Global Code Week, there is Girls' Day, DevOps for Kids. There are lots of local offers when you start looking for them. Also, it's always a good idea to look into what universities offer and what companies offer. For example, where I work, we do have child events from time to time because lots of us have a lot of fun doing that with kids. So you might find opportunities there. And if your child likes to do things with their friends, or a group of children is interested in learning how to code, or they want to connect with other kids, there are coding clubs like Coder Dojo or the Code Club. And now lots of other resources at the end of the slide deck that you can take a look at later. Now, last but not least, I want to talk about how children learn. I divided this into several sections. Let's start with the setup. So no matter at what age you introduce children to coding, one key element is to empower them to create things that are relevant to them. So they should be allowed to follow their own interests, because above else, learning and learning how to code should be a fun activity for children. So make sure that learning, is entertaining. Then children benefit from having a variety of learning experiences. So, for example, you can use real-life situations to explain concepts like loops. Like if you bake cookies, you can say, while we preheat the oven, we can already prepare the cookie batter. Or like come up with your own examples and do not only do it theoretically, sitting in front of a laptop, but try to introduce it into everyday life. And then don't be afraid to switch tracks if something isn't working. It can be a journey to find what works for you and your child, and it might need a lot of adjustment, so don't be afraid to make changes. Then learning sessions. First of all, use spaced learning, so distribute learning sessions over time. A single long session is usually less effective than multiple shorter ones, because having multiple shorter lessons helps to transfer knowledge to our long-term memory. This also applies to adults, by the way, and it prevents cognitive fatigue. Then regarding the question, active recall testing, sorry, I almost forgot about that. So you should ask questions to encourage the active retrieval of learned information. So do not just explain something or let them read something, but ask them to explain themselves how they understand what a loop is. It really helps the brain to deepen the knowledge and become a better learner. And then regarding the questions how long learning sessions should be, there is no one-size-fits-all answer. We do know that attention spans increase with age. So it's important to observe your child, see if it's still focused, if they are still enthusiastic about continuing the learning session, and then decide whether you keep learning. Last but not least, how can you support them while they are learning? Most importantly, be patient, so offer words of encouragement to keep them going if they are struggling. This goes hand in hand with encouraging your child to try new things and keep them going if they are struggling, and keep praising your child for trying new things. I think this is one of the most important takeaways for learning, that you do not, that you're not afraid of challenges, but you learn to love challenges and love failing, and really understand that learning is not about achieving everything that you want to achieve, but also to fail and to try again and to try in a different way. This is a very, very important skill for life and for learning. And then learn together with your kids. So for example, you can make learning a family activity, sit down together, you can let them be the expert sometimes, explain concepts to you, and show an interest in what they are doing. Let them talk about their projects, what they're struggling with, what they're enjoying, and be part of what they are trying to achieve. And now the Q&A section. I have 3 questions prepared because I'm asked about them a lot. First of all is, should children get started in their native language? I would always say yes, especially with large language models. We have lots of resources available for different languages. Having access to projects in our native language helps foster our confidence and independence, and as a result, we become more engaged with the learning process. What if my child doesn't like coding? There are different approaches. First of all, do not force anything. Try to find a way that they have fun doing it, maybe try again at a later stage. We know that kids have different passions at different ages. And if nothing works, then in the end, not all kids have to like coding and have to learn how to code. And there are other ways to teach these concepts. And about children with learning disabilities, there is no resource that lists all the learning disabilities and the ways which you can, or the tools that exist. But for example, there is Microsoft CodeJumper, which introduces kids with low vision to coding. There are also offers for ADHD and other learning disabilities. So that's it. Thank you so much for listening and excited to hear your questions.